Okay, so here we are in Chapter 5. And Chapter 5 is all about probability. And it's also secondarily about statistics. Specifically, data collection, or collecting data. So I want to give you a brief introduction here to Chapter 5. First off, we're going to talk about probability. I'm going to give you some basic ideas of probability in far as with some dice, and then opposite. And, if a chance of rain is 30%, chance it won't rain is 70%. You're probably familiar with a lot of that already. And also we'll look at some probability in tables. For any professional job, you'll need to be able to read tables. Well, not any, but for a lot of professional jobs, you'll need to be able to read tables, and so I'll have a lot of probability tables that you'll read from. So I'm going to dive right into the second part, though, in this introduction, because this is my favorite part in the whole course. So this is basically part 2. So part 1 of the chapter is the probability right here. That's part 1, and that'll be the tables and learning to read tables that have probability in them. Part 2 is the beginning of statistics. We'll also do some more statistics in Chapter 6. In fact, all of Chapter 6 will be devoted to computing statistics. But this part 2 of Chapter 5 is just about how we collect data, how we gather information. To me, this is the most important part of the entire course. And I think also the most interesting. So I want to show you that right now. So specifically, I've got this question right in front of you that I just wrote all over. Let me get rid of some of this, so that we can see what we've got here. And in fact, I'm just going to go into Chapter 5. This is the statistics. Part 2. So this is question number 14 from the statistics part 2 part of Chapter 5. Look at this question. When we take the 50 states and record the number of Boy Scouts in each state, so this is the United States of America, we take the 50 states, we record the number of Boy Scouts in each state, and 10 years later, we record the number of men who commit crimes in each state, we find that states with a larger number of Boy Scouts also have a larger number of crimes committed. And those states with fewer Boy Scouts also have fewer crimes committed. Now, I'm not making this up. This is the complete true facts. I don't know if you were aware of that. This is true. If you take the 50 states in the United States of America, you go state by state, California, Vermont, New Jersey, Texas, et cetera, et cetera. You run and you say, what's the number of Boy Scouts? Number of Boy Scouts, and then 10 years later, you find the number of crimes committed. Basically, the states that have more Boy Scouts 10 years later have more crimes. And the states that have less Boy Scouts 10 years later have less crimes committed. Do you get it? The Boy Scouts are cranking out criminals. Right? This proves it. This is a true fact. I am not exaggerating. I am not making up false data. If you go California, Vermont, New Jersey, Texas, on and on and on you go through the 50 states, and you take the number of Boy Scouts in each state, 10 years later the number of crimes committed, you can look up the data. It is true. The states that have more Boy Scouts, 10 years later have more crimes. The states that have less Boy Scouts, 10 years later, less crimes. So the more Boy Scouts you have, the more crimes you have 10 years later. The less Boy Scouts you have, the less crimes you have 10 years later. That is true. So, therefore, the Boy Scouts are producing criminals. Clearly proven. We better close down the Boy Scouts. No, of course not. That's the wrong conclusion. The Boy Scouts are not cranking out criminals. Well, I thought you might be saying, well, I thought you said this is true. Well, what's true is this paragraph and what I said over here. That's all true. What's not true is that the Boy Scouts are causing criminals or making criminals. What I'm showing you in this problem is how easy it is to get confused with statistical information. And this is super important because we live in the information age. Information's pouring at us all the time. Let's go back over this again. What in the world is going on here? How can states that have more Boy Scouts 10 years later have more crimes? That's true. And states that have less Boy Scouts 10 years later have less crimes? That's true. So therefore, Boy Scouts are causing crimes, producing criminals. That's not true. Well, how can one be true and the other not be true? Here's the deal. That what should we conclude from this? Well, here's what's happening behind the scenes. The Boy Scouts are not causing, they're not causing crimes to be committed. Crimes. They're not causing it. Boy Scouts are associated with crimes. The number of Boy Scouts is associated with the number of crimes. The number of Boy Scouts is associated with the number of crimes, but it's not causing it. Well, how can this be? Well, how this can be is there something else causing both of those. Do you know what it is? Have you figured it out? It's simply population, right? States with a higher population, let me write it here, states with more people, higher population, like California, where we have the most people of any state, states with more people have more Boy Scouts and more criminals, more crimes. And they have more honest people, and they have more Girl Scouts, and they have more everything because they have more people. California does than Vermont, say. You see, the Boy Scouts are not causing crimes to be committed. That's not what's going on here. Population is what we call the hidden variable. It's causing both of these. Right? When we go state by state and we find the states that have more Boy Scouts, that's just because they have more people, like California. And of course, they also have more crimes. They also have more honest people. They have more everything. They got more people. So I want you to see how easy it is to sort of lie with statistics and to make people think something that's not true. So here's your first video question. Video question number 1. It's this, and the answer is right here. That's the answer. What should we conclude from this? Association is not the same as causation. Just because the number of Boy Scouts and the number of crimes are associated, right? They're associated doesn't mean causation. Just because two things are connected doesn't mean one of them is causing the other. That's what you have to be careful about. Especially in today's world, the information age. This is modern mathematics, and I want to help you especially in this chapter, I want to help you to be a wise consumer in the information age, to take in all this information and be wise, and don't let people fool you with their statistics. I want to give you the mathematical understanding. So here's one key point. Association is not the same as causation. Just because two things are connected doesn't mean one is causing the other. Maybe something else, in this case population, more people, is causing them both. Okay, then you might ask, okay, I get that, Mr. Heron, but then sometimes things do cause other things. How do we know when they do? And that's a great question, and let me jump down here and answer that. Let's go to question 20 here. This is from part 2. This is chapter 5, part 2 in your homework again. My favorite chapter, my favorite section, most helpful to you, I think, most interesting. Chapter 5, part 2. Here's it's a funny looking 5. There we go. Here's question number 20. At a certain college, some students went to the tutorial center and some did not, right? That happens at every college. Records showed that those who went to tutoring had a 30% higher pass rate. So what does this mean? Does this mean, so does this prove that tutoring causes a higher pass rate? That's really the issue. We'll get into these other words over here in a minute. That's really the question that's, that this begs. It begs this question, doesn't it? Right? So some of the students went to the tutorial center, some did not. Those who went to record show, those who went to tutoring, 30% higher pass rate. So does this statistical evidence prove that tutoring causes a higher pass rate? The answer is no. Why not? Right? Those who went to tutoring had a higher pass rate, so tutoring is causing. Remember, the whole key is, how do you know when one thing is causing another? The problem with this is this. This is what we call, let me show you the problem here. The problem with this is it's an observational study. What does that mean, observational? It's observational. We only observed those who went to tutoring or did not. What am I talking about? Why is that? So what? We observed them. Well, the issue is this. You see, those that went to tutoring, they might have been better students on their own anyway. Maybe not. We don't know for sure. Remember, the whole thing is proved. Does this prove? The fact is, it says some of the students went to the tutorial center and some did not. Probably these are just better students, right? They chose to go to the tutorial center on their own. They were probably going to get better grades anyway. It could be that the tutorial center was actually no help at all, and these guys were already better students because they chose to go to the tutorial center. All we did was observe those who went to tutoring and those who did not, and we just noticed, hey, those who went did better. Well, it doesn't mean necessarily that the tutorial center caused that. They might have been better students already. They were choosing to go to tutoring on their own. The others were not. Probably they were better students already. Okay, well then, what's the deal? How do we prove causation? That's question 21 right here. Let's do this tutorial thing again. At a certain college, now we're going to do it different. 100 students were randomly broken into two groups of 50 each. The first group of 50 was regularly given time at the tutorial center. The second group of 50 was not given time at the tutorial center. Records show that those who went to tutoring had a 30% higher pass rate. Does this prove or provide strong evidence for tutoring raises the pass rate? And our answer is yes. Why? Because this is an experimental study. This is an experimental study. You see the difference? Here, we just took 100 students at random. And by the way, this is video question number 2. Video question number 2. It's going to be, how do you determine causation? How do you show one thing causes the other? The answer is you've got to do something experimental, not something observational like the last problem. You see the difference here? We took 100 people at random and broke them into two groups of 50 each. So there's some good students in each group. There's some bad students in each group. They're just random groups. And then the first group got tutoring, the other group didn't. And so any difference in the outcome, 30% higher pass rate, the only difference between those two groups is one group got tutoring, one group didn't. So if there's a different result, yes, that's evidence that tutoring made a difference. You see, that's an experiment. Whereas back here on this last problem, you might say, well, same thing, right? Some got tutoring, some not. Yeah, but there's other differences, right? The first group is a group that chose on their own to go to tutoring. So that implies a lot of different characteristics already about that group. There's a lot more different between those groups other than, in question 20 here, other than just one group went to tutoring, one did not? Right? Because we didn't force the two groups. They chose on their own. So that means this group who chose on their own to go to tutoring, they're probably more disciplined, more interested in passing, more careful about their studies, on and on and on. All those other things could be what caused them to pass better, not just the tutoring they received, right? Because the fact that we allowed them to choose means there was a lot of difference between the choosers and the not choosers already in their life that made them a person that would choose to go to tutoring versus those who did not. There's a lot of other differences other than the tutoring they received. So we can't be sure that it was the tutoring that caused something. This is exactly how they test new drugs, new medical treatments and procedures and surgeries. You have to come down here and do an experiment. See, this up here was just observational. We just looked. We didn't force two separate groups at random, one group getting tutoring, one group not. We just observed. So this is really important in the society in which we live. All the time, you'll read on the news almost every night. You'll see observational studies, and people will try to determine causation. You cannot determine causation by simply looking at what happens. Why not? Because there's a lot of differences between the two groups other than just the one thing. It could be a million things causing the pass rate to be higher. These are people that chose to go to tutoring. They have a lot more discipline and initiative. Whereas if you want to determine causation, how do you determine causation? You've got to do an experiment. And what's an experiment? You break into two groups randomly so that all the other characteristics, intelligence, discipline, organization, initiative, hard work, all that is randomly broken. There's not more smart people in one group than the other. There's not more hard workers in one group than the other. They're just randomly broken into two groups. And then you make the difference. You give one group the tutoring, the other group the no tutoring. So the only difference between those groups at that point is the tutoring. So any different outcome in the results must be because of the tutoring. Yes, that would provide strong evidence that the tutoring is causing the difference because there's nothing else different about those two groups. That's an experiment. That's how they test new drugs and new medical treatments. They'll break 100 people randomly into two groups and give 50 the drug and 50 the placebo. Well, you'll get into that, which is a fake drug, just a sugar pill to make them think they got the drug, and then they'll test the results at the end. That's exactly how the Drug Administration tests new products, and that's how sociologists test it. So it's important that you understand in the information age the difference between an observational situation where you just observe results and an experiment where you force two different groups at random and give one group the treatment, the tutoring, the other group not. Then and only then can you say we have strong evidence that the tutoring made a difference. So that's the introduction to Chapter 5, my favorite chapter in this course. I hope it benefits you, and I hope you enjoy thinking about these.